So, hello everyone, welcome back. It seems like some people are still enjoying their lunch, but nevertheless, time is running, so we'll continue with our presentations. And we have Mr. Adrian Winckles from I guess England. Yeah.
Yes.
The UK. Okay, so best of luck.
Okay. Thank you very much. Just to introduce myself, I'm, as you'll see from my presentation, I have a lot to do with OWASP in the UK, and particularly I'm going to be talking about honeypots and web threat intelligence through the use of web application firewalls, as an example. 2 or 3 quick facts about myself. In the day job, I'm an academic. I'm a security researcher at Anglia Ruskin University in Cambridge, but I manage the OWASP Cambridge chapter. I'm a European board member, and I run some OWASP European projects as well, and I do a few other industry bits and pieces, but I won't dwell too much on that. So you ask yourself, honeypots aren't anything new. We've been developing honeypots. We're tempting people to dip into hack particular systems to give away their secrets. We've been using things like Kippo, for example, for a long time to trap interactive sessions with secure shell. But why concentrate on web? Why should that be of importance to us? Particularly, one of the reasons is, according to CADA, for example, that 85% of internet traffic is HTTPS. If you look at stats from the National Institute of Standards and Technology in the States and quotes from Gartner, 92% of vulnerabilities in modern computer systems are in the application. And when they're in the application, we are talking particularly web applications. Oops. So that's what most of the stats will support that it's HTTPS, it's HTTP. Yes, there are other protocols we're running, but particularly for interactive sessions and for scripted attacks, it's going to be web-related intelligence that we're after. So, in particular, many of the web applications we develop, the web architecture is complicated. It's not just one system. Often there are multiple authentication systems. There's backends using various forms of MySQL, etc. The attacks on that sort of infrastructure are going to be complicated as well. And even those attacks that only affect 0.1, 0.01% of users, we want to know about them because they might be the ones that result in the larger data breaches, for example. It's this complication of different platforms, different web servers, different technologies that makes the attack surface very large. What we need to be able to do as security professionals is gain data on how people are attacking our web infrastructure. The problem sort of comes because of the diversity attacks is high as well. We can have attacks on servers, attacks on the client, attacks on a client via the server, attacks on a server via another server, and attacks on intermediaries. It's very much the attacks on intermediaries that actually get through and cause the data breaches, for example. One of the things we've done very much to protect ourselves, particularly in server-related installations, is to put a WAF. Everyone's heard of a WAF, a web application firewall, in between the web server and the web client, to effectively stop known web attacks. Sometimes we don't want to stop, we want to learn from what people are doing. So can we use WAF technology in a honeypot or in a probe? Essentially, this is what we're doing, or this is what we want to do as part of the OWASP Web Honeypot project. But of course, WAFs come in many different forms. We can put them in line, out of line, on the web server itself. We can make them signature-based, heuristic-based. They're often driven by PCI DSS requirements, for example, because it's an approved security control. You start asking yourself, so is there any difference between a WAF and an IDS? We use both, but could we use a WAF as some sort of detection device to give us more intelligence? I think the answer is yes. Oops. So, obviously, doing work with OWASP, we come from an open source background. So it makes sense to use an open source web application firewall. The main one that's bundled in with things like Nginx and Apache is Mod Security. Probably the most popular WAF. It's been around, it has a vintage, it's been around since 2002. We're tinkering around the edges of version 3 at the moment. But it's not just the web application firewall. You need the rules as well, and the rules are going to be very complicated. There is an open source project, the OWASP Core Rule Set, CRS. Again, has been around about 9 years, since about 2009. It's providing a 3 generic rule set for mod security users. This is something we could probably use and enhance within a probe honeypot type environment. And of course there's lots of opportunities for the types of attacks, for the types of breaches that may come from the use of a web and the web application. So what is the core rule set? Essentially it's a set of generic plug and play WAF rules that you can insert into something like mod security, and it has, as you'd expect, a range of detection categories, things like protocol validation, malicious client identification, for example, Trojan backdoor access, outdoor data leakage, antivirus and DOS utility scripts. There's lots of things built into CRS, and it has matured because we're on version 3. It's matured and is something that is being used by most of the major web server suppliers. So it's approved technology, but really we want to be able to use it in a sort of honeypot, in a sort of probe type environment, so we can pick up intelligence, effectively web intelligence from from both automated and from manual style attacks as well. Because core rule set can be put in IDS mode. It can be self-contained with a set of rules. It could be used for something that could be updated, and I'll talk a bit later about maybe how could we use AI or machine learning in that context. The rules are stateless. There's no intelligence shared between rules. If a rule is triggered, it generates a logging action. It records something. Why keep that log on one web server? Why not use it as community threat intelligence? So effectively, we've got something that will generate our alarms, will generate our threat intelligence data. We can run it in standard event logging mode. Rules basically trigger a push entry using HTTP that you can push using something called mlogc, which is part of the background auditing tools. It pushes it into an audit log that you can then push into almost whatever format you want. It's easy to push it into something like MySQL, for example, or we could use something like a correlated mode, where, if you like, the basic rules are considered as reference events, and they don't go in the error log. But we're really after intelligence, so maybe the standard mode is probably more useful for ourselves. So what are we aiming to do with this OWASP project? It's really about finding real-time, detailed web application attack data. It's taking data that we can take from a number of probes scattered around the world, both in cloud environments, as standalone probes, in small factor computing platforms, and have the report back to a central console. Then the threat reports are made available to the community. And there's some work at the moment to see what the best format that can be made available in. So how does the architecture work? Effectively, what we're doing is we're waiting for attackers to attack or discover there's a web server running on a probe. They obviously do a sort of inbound scanning attack or something of nature, and you generate a 200 status code to say that the web server has accepted it. And what the sensor does, because it's running mod security, it effectively generates an alarm with threat intelligence data. It pushes it to a central logging server where the event can be analysed by an analyst or analysed by the community. The work we're doing at the moment is, can we generate that into some sort of threat intelligence format like Sticks, for example, or other projects? The Honeypot could be deployed by itself. It could be deployed in front of a target site. There are different ways that the functionality could be actioned. As I said, the important thing is that we have probes deployed in lots of locations to pick up threat intelligence data from different places around the world, centralise them on a central console, and make that data available as threat intelligence data to anyone that wants it. One of the things we saw, because lots of people concentrate on some shared threat intelligence data when people are knocking on the front door. But very often there are other considerations that maybe their local WAF picks up, but there's a rear access, there's a back end that isn't very often considered. And if we can provide the threat intelligence data on that, it could save a potential data breach in particular situations. You can pick up simple web attacks, who's doing a particular request, a particular scan, but you want to be able to take out the essential data from that and present it so not just what is the attacking IP address, but what are they actually putting within the HTTP packet? What is it that they're actually trying to do? What can you flag up? If people are actually trying to run multiple types of command or multiple types of attack, can we make that available to the community? So we're trying to do a lot of things. First, we've proved the proof of concept. We've taken an old project, we've rebooted it, developed using the CRS existing software in a virtual machine that's deployable as an instance in, for example, Amazon Web Services. We've proved that we can push the logs into HTTP, receiving PHP script, put it into MySQL. What we're interested in is developing a console option. Can we create an audit? Can we make those audit logs available as they are, or is this something that we want to develop a sort of new sort of front end? We've tested from multiple probes in multiple locations. What we're keen to do is try and convert from the MySQL format for put into something like a JSON format, for example. Maybe enhance the mlogc mechanism for pushing into HTTP. And it might be useful, can we push, if we can convert it into JSON format, can we push that straight into something like Elasticsearch or Logstash, something like that? Kubernetes, perhaps, to visualize the data better, that makes it more applicable to the community. Some of the interesting work would be a mechanism to forward honest output into threat intelligence in Sticks format I mentioned, or something like the MIST project. so that intelligence data can be shared with the community. Possibly taxi format, but something that we've got a system that will hold this threat intelligence data that is useful to end users. Consider maybe a new log transfer engine for example, mlogc could be a new transfer agent. And at the moment we're running on CRS version 2.09. CRS is now at version 3. We really want to support that, so we're in tandem with what's being supported in the community in the conventional use of a WAF. I'd like to see Honeypot probes available as not just a VM or a cloud instance. Can we deploy them into something like Docker, for example? Could we deploy it into low-end computing devices so you could plug a black box to a data center in sort of a Raspberry Pi or Wino type format? And where I think the exciting part of the journey is, can we apply some sort of machine learning techniques effectively so we can actually take the ability to automate what's been learnt, and so it can be fed back into the probe, into the honeypot, to update it. So if there are new attacks, new attack data that come in, can it automatically update CRS, the core rule set, to actually incorporate that data so it is more effective? That would be a good use of machine learning in this context, I think. So I think that's quicker than I anticipated. Any questions? Still have 13 minutes, okay.
Maybe just anyone has a story to tell. Okay, one question there. Can we?
Yep, yep.
Okay.
Please. Can you tell how do you make these honeypots to appeal very likably to get interest to attack to them?
So if you wanted to deploy one of these honeypots, where can you get it from? Is that what you're saying?
Why do somebody want to attack them?
If someone did, how do you make it attractive? You could deploy the honeypot alongside your load balancer, for example, as part of your deployment of your conventional web servers. Its natural role is as a proxy anyway, so it could still feed the normal attack through, but flag it and then wait for something else to kill the connection afterwards. You could deploy it as a separate VM, standalone by itself. So it's just, as with any system, it's picked up in some sort of scanning activity. You could, if you wanted to, employ extra details of a website within the probe itself. If you wanted to add it, make it as a false looking web application. But because it's open source code, you could adapt it to how you want it effectively. I'm looking at it from a threat intelligence point of view because we can get some generic and learn some interesting information. But it could be tailored to whatever need was needed.
I think there was one more question. So one of your slides also was showing the attack vector are coming from client to server, from server to client, but you also forgot to mention there is a lot of I/O devices like cameras. And the second one points to the making your honeypot more attractive, and using the Raspberry Pi is not a very good option, by the way, because the Raspberry Pi has USB connected Ethernet and it's quite slow and it's not working properly. But the web servers, they are not just staying on one single port. Right now there is a lot of services running on specific ports, and they quite often becoming like a point of attack then the people are especially scanning for vulnerable cameras, for vulnerable CO devices, and then using them to attack the web servers.
So for example, you could tailor mod security to point at not just port 80, port 8080, 8888, or whatever ports you wanted to point it at. It doesn't. The idea of a generic honeypot is that it picks up some of the general HTTP type attacks and HTTPS attacks. If you wanted to tailor it to a particular situation, you could very easily configure, and you would develop. You were trying to attract people to attack a specific type of web application, for example. You could tailor it to monitor on those ports as well. No, there's no, because the WAF goes in front of a particular website or particular web application. There's no reason why you can't tailor it to detect on that as well. If that makes sense.
Any more questions?
Are you planning to publish your data?
No, so this data will. The idea of using these sort of generic honeypots is that we make threat intelligence available to the community. So we put it into something like sticks format. Sorry?
In real time?
If that is possible, yes. I mean, one of the things we'd like to get it into something like Elasticsearch, as well as how much of anything is ever real time. There's always a lag between getting the information, processing and pushing it through. But that would be an intention, yes, to make it available as soon as we have it into the community. So it should not require vetting by a human to put it through. I think there was another question at the back.
One more question?
Yes, thank you. In case of embedded platforms where we cannot change the web server and application, can we use this technology to have something like intrusion prevention system?
I guess this has been designed very much as a detection mechanism for threat intelligence. I guess if you had an action into something like a CM system, SIME system, that detected that particular type of attack, it could trigger an action going back to some sort of intrusion. It's not designed as an intrusion prevention system, so it doesn't cut connections there and then. But as with any firewall rule, if you did want to use it in its true WAF format, you could get it to automatically block, yes.
How I understand your this system of Honeypot is idea is to get information about attacks, but have you assessed how vulnerable is this system and how what risks will be assessed on infrastructure where is this Honeypot hosted?
So you're saying if someone was to actually hack into the honeypot itself, could they compromise somebody's infrastructure? I guess it's up to every individual organisation where they wanted to deploy something like this. If it was deployed in the cloud alongside other systems, then it's as vulnerable as anything else that sits there. If you were looking for this as part of your in-depth defence and you were putting it at the heart of your data center and you were worried about systems being compromised, then perhaps you wouldn't deploy it in mission critical situations. Maybe you would put it on the edge of your demilitarized zone or something like that as something that would be potentially at risk. As with any sort of intelligence gathering device or proxy is always potentially at risk in those sort of areas anyway. Okay.
So then we would like to thank you from the organizers part, and this is a small gift from DSS. Here you are. Thank you for coming.